Hi, this is Andrew Von Egge with Aerohive Networks, and we're continuing our wireless video series on high-density Wi-Fi network design and configuration. Today I'd like to talk to you a little bit about configuring the network and performance enhancement features to make sure your network performs optimally under high load. The first thing you want to consider is the appropriate use of encryption. Encryption is very important so you can get use of 802.11n high throughput rates. You want to make sure that you use WPA2 encryption with AES CCMP. Or, alternatively, for a guest network, use an open network with no encryption. One of those two types of encryption methods are required to use high throughput rates. Second, you want to make sure that you enable WMM or QoS to prioritize key applications. WMM is also required for 802.11n rates, and by prioritizing key applications above and beyond that through QoS policy configuration, you can make sure that the business applications or the applications that your users are going to be using will perform optimally under heavy load on the network. Next, we want to make sure that you disable the low data rates. This is important to make sure that clients stay connected at the highest data rates possible to minimize airtime utilization. We talked about this a little bit in video number 2 for designing your RF, because we wanted to make sure that we designed to a neg 67 dBm boundary for client associations to the access point. By doing that RF design, we can then disable the low data rates to make sure clients stay connected at the high data rates and transfer the data as optimally and efficiently as possible. The last thing around bandwidth that you want to be thinking about is potentially enabling client rate limiting. This is important because with influx of a lot of mobile devices and just a lot of devices in general on a high-density network, you want to make sure any one or subset of devices aren't greedy with the bandwidth on the network. Think about mobile devices using social media and cloud data backups frequently now. There could be a lot of upload traffic to the cloud, and you want to make sure that no one user monopolizes that bandwidth on the access point. So client rate limiting can be an optional feature for you, but something that could be very important. Next, we'll talk about high performance and performance enhancement features that can optimize the use of the high-density network. The first of these is band steering. And at Aerohive, we like to talk about bi-directional band steering because it's very important as mobile devices and newer devices actually prefer 5 gigahertz technology or frequency bands, that you actually have the ability to shift clients in either direction between the 2.4 and 5 gigahertz radios. This ties back in again with the RF network design that we talked about in video number 2, because if you are co-locating access points, you want to make sure that you can distribute the client load across those access points and across those radios and the frequencies as optimally as possible. So if you're co-locating access points and you have more 5 gigahertz capacity in a physical area than you do 2.4 gigahertz capacity, you want to make sure you optimally split the clients between those channels to segment them, to reduce medium contention, and improve aggregate performance on the network. The second thing you want to think about is client load balancing. Client load balancing distributes clients between different access points based on real-time airtime utilization and characteristics on the frequencies the access points are operating on. Finally, you want to talk about airtime fairness and client SLA. Airtime fairness is very important to make sure that slower speed clients don't monopolize airtime versus high-speed clients. So, for instance, using typical or standard wireless network medium contention, stations have access based on packet level fairness, we call this. And this means a high throughput station can transmit 1 frame and then a slow speed device can transmit 1 frame. What this ends up with is the high-speed clients can transmit their data much, much faster, and they're on the airtime for very small amounts of time. Whereas the slow-speed client takes much longer because they're using a lower data rate to transmit even the same amount of data. This ends up in an unequal balance of airtime across stations. The slow-speed clients end up monopolizing the airtime and significantly degrading the performance of the high-speed client. With airtime fairness, we can actually make it not based on packet level fairness, but based on airtime. This allows the high-speed client, such as, let's say, a 3-stream 802.11n client, to take advantage of more airtime and push more data through the network. Whereas we take very little actual bandwidth away from the slow-speed client because the airtime that we're taking away from them, they couldn't actually get much data through anyways. The analogy that I like to use in this situation is like talking to somebody on the phone who is just an avid talker. They won't let you get a word in edgewise. If you're able to take control of the conversation and have a balanced conversation, both parties get to talk equally. And that's kind of like what Airtime Fairness does for us. Finally, we want to have some wired network considerations that I like to talk about. Wired networking is often a last consideration or even forgotten about portion of high-density Wi-Fi network design. We want to make sure that access points are all connected to gigabit Ethernet switches, especially with 802.11n access points, where we can push potentially 450 megabits raw data rate through each radio, which would then be about 280 or so TCP/IP of throughput. So we need to make sure we have more than just a fast Ethernet connection on those access points. We also want to make sure we have sufficient power over Ethernet. This was a bigger problem with first generation 802.11n access points. Most current generation 11n APs support operation within standard 802.3 AF PoE. However, as we migrate to 802.11 AC, we're going to start to be challenged to make sure that we have sufficient PoE plus ports to power those access points to get all of the features and all of the antenna and performance out of those access points that they're capable of. Make sure you have radius server redundancy in case you're doing 802.1x authentication over the network, to make sure if you have a radius server problem, you can still maintain operation of the network. And ideally, that radius server or multiple radius servers should be local on the LAN as well, not across a high latency WAN link. IP addressing and subnet sizing can be a big concern if you're going to have multiple VLANs and subnets that serve your high density network. Typically you want to bundle in a plan for about 2 to 3 devices per user. So make sure you have sufficient subnet size to handle those users. And if you're worried about broadcast and domains and you want smaller VLANs, if you have multiple VLANs, then you need to be worried about user mobility across VLANs as well. This is very common if people put laptops to sleep, or if there's a break in coverage where users can't seamlessly roam between access points. They will actually reattach to the network and grab a new IP address from a different subnet and actually be utilizing multiple IP addresses out of multiple different subnets at the same time. Therefore, we typically recommend you allocate 25% headroom for growth in general, and if you have user mobility with multiple subnets, perhaps upwards of at least more like 50% headroom to account for those variations as users move throughout the environment. Lastly, on the wired network, you want to make sure you take into consideration internet and WAN bandwidth. Internet and WAN bandwidth can be very problematic, especially for temporary events like conferences and trade shows. You want to make sure you typically account for maybe 10 megabits per second of actual bandwidth for every 100 users or devices that are going to be on the network. So make sure you have sufficient WAN bandwidth or internet bandwidth to support all the different users that are going to be on your network. You can find more information on all of these high-density Wi-Fi network design and configuration tips in the Aerohive High-Density Wi-Fi Design and Configuration Guide that is available on our website. Thank you for watching.